Now, we can do stoichiometry with solutions very similar to how we did it with math. Here we're going to be using with mass. So here we're going to be dealing with, instead of grams, and moles, which we are going to be dealing with moles, but we're going to be dealing with volumes and molarities. So instead of grams and molar mass, we're going to deal with volumes and molarities. Any way we do it, we're going to have to get to moles of whatever we're using to be able to use our balanced equation to get to moles or concentration of another substance. So this says what volume of a 0.150 molar nitric acid solution will completely react with 35.7 milliliters of 0.108 molar sodium carbonate solution. Here's our reaction. Whoa, that probably just confused the heck out of all of y'all. Okay, start with what you're given when you're given the volume and the concentration. So start there. Molarity is always going to be a conversion factor here. So start with this. Okay, 35.7 milliliters Na2CO3. All right, now, remember, molarity is moles per liter. Mark that out, moles per liter. That'll help. Okay, so now we need to get to moles. We can get to moles through molarity. Well, molarity is in liters, and we're in milliliters. So let's get to liters. So 1,000 milliliters is 1 liter. That helps. Okay, now we're in liters. Now let's use our molarity that matches up. Make sure you match them up. So here we're with sodium carbonate. Stay with sodium carbonate. So 0.108 moles sodium carbonate per liter. Liters are gone. Look, now we're in moles. So this is like when you go from grams and using your molar mass. But instead of molar mass, we're using molarity to get to moles. Okay, now we go sodium carbonate, find it in the equation. There it is. How many moles? 1. 1 mole sodium carbonate gives us volume of nitric acid. There's nitric acid, 2 moles. 2 moles nitric acid. Okay? Now, what's the question asking us to find? Volume of nitric acid. We have moles of nitric acid. How do we get from moles to volume? We know the molarity. Now this time we're going to have to use molarity upside down because we want moles to go in the bottom and we want volume on the top. So 0.150 moles nitric acid per liter. Now this does not specify what unit, whether liters or milliliters. I'm going to say since we went to we started with milliliters, we're probably going to finish with milliliters, but since it doesn't specifically ask, it's not required. A shortcut that I sometimes use when I'm given these kinds of things is when I write my molarity, like I can write 0.108 moles per 1,000 milliliters and just kind of do that conversion in 1. Means the same thing. If you like that, great. If you don't do it that way. Now we're ready to calculate. Now some of you are going to want to do this as a dilution. It will not work because look, our mole ratio is different. You cannot process this using an M1V1 equals M2V2. It does not work. I will not give you one on the test where it works that way. So you have to know the process. 2 times 1,000. Or you can say, oh, look, the thousands cancel out. But I multiplied by 1,000, so I'm going to divide by 1,000 this time. Divided by 0.150. So here I get 51.4. 51.4 milliliters of nitric acid. This is why it's important to make sure you know what substances you're using. Because if you just start writing moles everywhere, you're going to get confused. Okay, now here we're still starting with 35.7, and we want to know how many grams of carbon dioxide forms. Ooh, can we do that? Yes, we can. Start with what you're given, 35.7 milliliters Na2CO3. Get to moles. So here I'm going to use my little shortcut, 0.108 moles of Na2CO3 per 1,000 milliliters. That makes things easy. Now that I'm in moles, we want carbon dioxide. So find carbon dioxide. So here, 1 to 1. 1 mole Na2CO3, 1 mole carbon dioxide. Now this wants grams of carbon dioxide. Can we get from moles to grams? Yes, we can. Molar mass. So 1 mole CO2, 44.01 grams CO2. Use your periodic table if you need to add that up. That's fine. Now we're ready to multiply. 35.7 times 0.108 times 44.01 divided by 1,000. So 0.170 for using 3 significant figures grams CO2.